Hello, my name is David Madden. I'm the Senior Director of Business Development at Thales, and today we are here with Ellen Boehm, VP of IoT Strategy and Operations at our great partner Keyfactor, to do a Talking Trust session on IoT. During our session today, we're going to focus on security and how it relates to vehicles and their supply chain. The promise of IoT, as you know, has been hyped over the past 10 years, and the number of connected devices arriving in the market is growing exponentially. However, faster product development and feature delivery often take a priority to get offerings to market, leading to increased security risks, device hacks, and data theft. Modern PKI has emerged as an efficient and cost-effective way to secure embedded devices at scale, but only when it's done right. So we're very lucky to have with us an industry expert in the IoT and connected vehicle space, Ellen, to try and help make sense of the current state of the IoT security across the ecosystem. So let's get started with discussing how she views the risks in connected vehicles and how it is so hard to address this in a secure and scalable way.
Sounds good. Thanks for having me.
So let's start then with how we deal with this, these risks. Helen, maybe you could share a little bit on this first slide.
Yeah. So as you mentioned, Dave, there are a ton of benefits for why we want to connect vehicles, which is akin to, I think, just IoT in general, right? You have a product and adding it to the internet to be able to pull data from it and run analytics on how it's operating can help us in a ton of ways as manufacturers to be able to do more predictive maintenance, to be able to anticipate recalls and then manage warranty. From a vehicle standpoint, there's things around just safety and accident avoidance, or optimizing how it's running so that we can reduce emissions and the carbon footprint, or just mobility and infotainment, as people are now expecting their car to be this connectivity point to music or maybe video when you're on a long trip. And so those are the types of things that we just expect to now be within these cars. But how to then make sure that we secure these points of entry, really, right, into this vehicle that now we're driving down the road, got to make sure that it doesn't get hacked into. There's a lot of complexity. And so that's why if we break it down into a couple different pieces here, why is it hard? Because it's attractive, it's interesting to think about hacking a car.
It's a challenge.
Can you imagine? Yeah.
Why do we climb it? Because it's there. Why do we hack it? Because we want to. We want to try.
Because we want to be the one to say, oh yeah, I was able to open up, this vehicle and drive it away, right? It's so that's kind of the first type of thing, is that hackers are kind of out there seeing what they can accomplish. The next one, design limitations. So within the hardware itself, within the vehicle, there can be constraints, processing power. There's certain physical things that are restrictions in the hardware that we have today that we kind of need to work within, but we have to make sure to have the capability to embed the right security into that, and the right software into that, and the right verification into the framework that we have. But by the way, while making sure that this lasts a really long time, because you buy a car, you're going to expect it to last for, I don't know how, 5, 7, 10 years in some cases.
Right.
So a couple other things to bring up here around why it's hard. So the complexity of the supply chain. Think about all of the different vendors from, and even just, if you don't know a lot about making vehicles, there's everything from the rubber that goes into the tires, and then the wheels, but then all these little connected parts, the engine control units, the central gateway modules, just the brains and the computer of the car, is a result of years and years of collaboration between multiple people. And when you have security now as going into that vehicle infrastructure as well, you have multiple people that need to all be on the same page with how we're going to do this. Right. So that can be really challenging.
Makes sense. So do we want to talk a little specifically about some of the risks related to vehicle compromises and some of the areas we should really think about?
Yeah, yes. So a couple things here. I think a lot of them, when you start to think about it, are kind of logical. So, what if I have a car and it has a capability to have a digital key fob, right? And it's on my phone. I recently read or I think it was end of last year, there was a story about an electrical vehicle manufacturer and a security researcher that was able to actually get into the car by exploiting some vulnerabilities around lack of validation of firmware to be able to basically spoof that key fob and use their phone to open the door and get inside, and then use that to pair it to the car and then start it up. So
Incredible.
it was, now again, I think bringing that to the attention of the manufacturer, they quickly had patches and things like that, and that's the kind of stuff that I think we as a security world need to be aware of, need to be looking for, need to figure out how to do better to and then share those stories so that everyone is aware that these threats are real. That we're doing our best with trying to build in security, but there's always going to be somebody trying to knock that down and try to get around it.
And I guess, Ellen, the neat thing here is when you mention that is they found about this vulnerability and they could quickly, as you say, patch it, because it sounds like a software update could address that. Whereas in the old days, you had to come up with a new safety recall, build a new part. Is that right? Like, was it fairly quick to implement?
Exactly. Yes. Yes. And so with over-the-air firmware updates, which is very commonplace in IoT solutions, it's always recommended that before you push code, you sign that firmware and you use a code signing certificate and you store the private key for that in an HSM, such as it comes with Talus solutions and Keyfactor solutions. So there's, I think, best practices that it's a starting point. Do that such that when you push out the firmware via your normal OTA process, and then the endpoint accepts that it will validate that firmware with a signature verification before installing it, and knowing who has this arrived to me from an authorized party, and should I actually install it so I can run the next feature or fix a bug. And that's, I think, where we talk about making sure that you're keeping hold of that certificate and key, because if anybody can get access to that, they can sign code as if they were you as a manufacturer, and that can be a little bit scary.
Because it's a true Trojan horse.
True Trojan, exactly. Because then the device would say, "Oh, it was signed by who I thought it was, supposed to be coming from," but it's malware. So there's, again, like I said, a couple different layers that we have to cover here and make sure that we're really secure.
So how do we address this then? How would you suggest perhaps an architecture to address these different risk vectors that we're seeing?
Yeah. So if we take a look at this page, it's kind of a high-level architecture of setting up a different layers of security within the IoT stack. Okay, so if we start at the bottom of this page and you think about the edge devices, so typically you have some IoT sensors, or in this case, you have a vehicle engine control unit. In some cases, there's a gateway that's aggregating data from these different edge sensors. The key is at that layer to understand what you need to do in terms of device identity and unique. We recommend using asymmetric certificates to be that unique. It's not duplicated across any other device out there in the world. Certificate based, piece of information that is tagged to that device that can be it can be embedded into the device, and ideally generated from a private key that is generated on that piece of hardware and doesn't ever leave the hardware. Employing secure boot. So you can do this in conjunction with firmware verification, like we talked about on the last page, and making sure that you start up the device only after you've validated that it's secure, and validated the origin.
So really,
So
what you're talking about is a layered model of security, which, as you probably are very well aware, it's been a industry best practice for well over, several decades now. Is that what you have in these different, layers, if you will, in the stack?
Exactly. Yeah. So after you figure out how you want to then layer in at the edge, right? It's what do you need to layer in at that management level? And then what do you need to do at the operations level? And the key point on the right-hand side is if you do this correctly, then, and you're encrypting your data at those edge points and you're using certificates and you're establishing secure connections, you can send that data across Wi-Fi or Bluetooth or whatever network you have within a vehicle, right? And then that data can be decrypted at by an authorized endpoint in the cloud, whatever application is looking at the data.
Right. And to your point, that data I'm hearing is the new goal from IoT. It's the data that drives all these different new business case and service models. Is that right?
Yes, that is 100% the case. And I think we've known that for a while. We've talked about the value of that. It opens so many different business models, especially when it comes to more traditional hardware-based industries that provide an asset, a very expensive asset that we're looking to optimize, whether that's a power turbine, whether that's some sort of industrial control system. There's a ton of things that can be monitored, that can be collected, that can be then analyzed and then used to then optimize the overall system. And that's where you open up different business opportunities, different services for your core business, or on top of your core business, I should say, which I think is super interesting to apply.
Very interesting point, Ellen. So let's talk about that a little more. Can you share some details on some of these use cases that you're starting to see?
Yeah. So let's talk about, so we kind of talked about connected vehicle a bit. I also want to touch on medical devices, because that's another space where we have some customers that are employing firmware signing and certificate-based authentication. So in this case here, let's just talk about an insulin pump, right? So you have a device that is attached to a patient and needs to deliver insulin, and so you have a identity that then is built into that device when it's produced. So that device has some sort of PCB, it has some electronics, it has a microprocessor, it has maybe a secure element place to store keys and certificates. And so when the device is produced, we have to figure out what's that identity and how do we provision that identity in the factory such that you can get that onto that board, right? And then it can get assembled into its end device. It can get packaged up and it can get shipped off into the world. So that's one thing that we talk about is like, what is the birth certificate and birth identity? Part of that is also, creating that key and how do you want to inject that key, which then creates the certificate for the device identity certificate. How do you do that? Where do you store that? There's different ways you can do that. Keyfactor and Talos can help you with establishing an infrastructure to then be able to create that uniquely.
Very interesting. And the interesting in both cases, you're dealing with public safety, whether it's a healthcare or connected vehicle. It's safety as well as the power of the data. It's protecting people and keeping them safe on one side, but also enabling new business models on the other. How would the cloud impact this as part of all these different use cases?
I'm sorry, I just broke up for a sec. How can we repeat the question?
How would the cloud impact this?
Yes. Yeah, definitely. So I think there's a lot more talk around do we analyze data at the edge because it's faster, or can we leverage different cloud platforms to do similar analysis? I think in many cases, we are looking to the cloud to be able to be more flexible, to in some cases to stand things up more quickly, to be flexible in, if I back to the manufacturing use case, right? So let's say you want to you switch where you're producing a bunch of your connected devices, okay? And you want to go to a different contract manufacturer, you want to outsource something of a new product line until you have capacity. So those types of things, you have to think about, how are you then going to stand up a new product, make sure that you're creating keys and certificates for it quickly. The cloud, I think, when implemented securely, is an excellent option to be able to help us stand things up in a faster way.
Makes sense. So now, what might if you put all these pieces together, if you will, what might a high-level IoT architecture look like in the automotive and healthcare market?
Yeah, so I think when we are looking at designing an overall architecture, it's starting with what are those identities that you want to create, and what type of underlying public key infrastructure, root CAs, issuing CAs. When I say CA, certificate authority, as you can see on the screen here, how do I design and create policies around all of that infrastructure to be able to generate certificates for the devices, the groups, the products within my business? Once that's kind of designed out, and think about where and who I need to access these pieces to create, the proper authentication within the factory, within the operations, within development. So item, here 1 and 2 here are what is the system that you're going to use to create these identities, and where does it need to live? You probably need to have some access on the factory floor. Perhaps you would need to have access in step number 2 for your firmware developers to be able to present code to be signed with that code signing certificate, so that then you can release firmware updates to be installed when they're initially produced, or sent into the normal firmware over-the-air update life cycle. You also have to consider what cloud IoT platforms that you might be using for overall device management. And in some cases, there's that's to take into consideration in conjunction with your own dedicated single tenant PKI, en route from which all your certificates come from. So those are kind of the different pieces. And then finally, step 4 there is just how you're actually getting this technology and this capability into your devices, so that when they are in the field and offline, that you can be able to do lifecycle management on these high value pieces of equipment, because we're putting in certificates and keys right now. We're using the best crypto algorithms that we have today. We also, though, know that things are going to change, and those algorithms are going to become outdated and weaker over time. So if you're making an asset and it's 15 years lifetime, you as an OEM is responsible for maintaining that. You're going to have to make sure that your security is also up to date to last just as long as the pieces of hardware within that system last. And so I think those are things that we want to think about, just from a whole overall start to finish. How do you build it? How do you maintain it? How do you do the whole life cycle piece? Very
interesting. And I think this is a great way to show a turnkey solution that Keyfactor and Talis are providing for automating the management of IoT lifecycle and complex, manufacturing supply chains like healthcare and connected vehicles, as you described, Ellen. And really, to put this in the context of the global pandemic, our friends at IDC have found that teams practicing this accelerated application delivery for new services using the cloud and IoT are in a much better position to respond to the crisis. They're able to roll out new services based on IoT in a much shorter time to help drive the shift in their classic business to a digital business. And I think automotive companies are really looking to IoT and to leverage cloud and services for their traditional car business. So thank you very much, Ellen, for taking the time today to share your insights into threats impacting IoT, connected vehicles, and healthcare, and how we all really need to rethink how we're approaching PKI identities, security policies, and their impact on enterprises as they digitally transform their business. Please see below for the links and get more details on how Keyfactor and Thales can help you secure, automate, and scale your IoT deployments.
Thanks, Dave.
Stay safe and have a great day.